today we are discussing the transformer and the classification of the transformer. The next type of classification is on the basis of the winding arrangement. So, transformer types based on winding arrangement are auto winding transformer, and the other type is also the secondary voltage where we are using. So, on the basis of the winding arrangement, we are having a auto winding transformer. In this type of windings, we have the primary and secondary windings have always been fixed, but with an auto winding transformer, they can be connected in the series and the center tapped node can be moved. So, the secondary voltage can be altered by changing the location of the central tap. So, the auto is used to alter the self or a single coil and is not the abbreviated of the automatic. It is not the automatic, but it is the self. Auto means self. So, it is used to alter the self or a single coil. So, this coil creates a ratio using the main and the secondary component. The main and secondary ratio is determined by the location of the center tap node. So, which changes the output voltage, that is the VAR-IAC, as a device that generates the variable AC, that is a variable AC. So, it is written as VAR-IAC. So, from a steady AC input, a device that generate variable AC from a steady AC input is used the most frequently. So, here auto self means here we are getting the varied output by using this auto winding transformer. So, another type of transformer is on the basis of its uses. So, first type of transformer that is based upon their proposed used transformer. So, first is that can be used and operate in the distinct field is the power transformer. So, the energy is transferred to the substation or the general electric supply using a larger power transformer. So, between the major distribution grid and the power generator, this transformer serves as a link. This power transformer just used for the major distribution of the grid and the power generator. So, power transformer can be further divided into three groups based upon their power rating and specification: low, medium and high. So, power transformer are mainly used in the transmission network of higher voltage. So, its ratings are as 400 kilowatt, 200 kilowatt, 1110 kilowatt, 66 kilowatt, 33 kilowatt. Most of the power transformer is rated above 200 megawatt ampere. So, they are installed at a generating station, transmission substations which needs a high capacity transformer. So, the power transformer is designed for maximum efficiency of almost 100% and is larger than the distribution transformer. So, as this is the power is work upon a very high voltage, the power cannot be distributed to the consumer directly because they need the smaller voltage. So, the power is stepped down to the desired level with the help of step down power transformer. So, after the power transformer, we use the step down power transformer just to lower the power to supply further. the transformer is not loaded fully, hence the core loss occurs for the whole day. But the copper loss is based on the load cycle of the distribution network. Suppose the power transformer is connected to the transmission network. In that case, the load fluctuation will be significantly less as it is not connected to the consumer and directly. So, still if connected to the distribution network, there will be fluctuations in the load. So, it is not directly connected. So, the transformer is loaded for 24 hours as a transmission station. Thus, the core and copper losses will occur for whole the day. Apart from that, the power transformer is cost effective when the power is generated at a low voltage level. If the voltage level is raised, the current of the power transformer is reduced and resulting in I square R losses, and the voltage regulation is also increased. Another type of transformer according to its utility is the distribution transformer. As we are using the power transformer, then further we use the distribution transformer. So, the distribution transformer are also as a consumption transformer. So, it is responsible for switching from a low medium voltage source to the voltage used for the home appliances and the industrial equipments. So, from the power, it is the distribution transformer we will use. So, distribution transformer are intended to reduce the voltage for distribution for the users or the commercial users, either in the home or in the industries. So, this machine has a good voltage regulation and can be operated 24 hours a day with the maximum efficiency at the 50% load. Another type of transformation in this category is the isolation transformer. So, the isolation transformer are transformer with the primary and the secondary winding independently to each other, and there is only a magnetic flux relationship between them. Means primary and secondary windings are independent and there is only a relationship, that is relationship is based on the magnetic flux. So, unlike auto transformers, isolating transformer are composed of the primary and secondary windings linked only through the magnetic field, as it is based upon the magnetic flux. So, it is linked only through the magnetic field. The bindings are separated so that they are electrically independent and form the distinct point of isolation, that is transformer. So, they are electrically independent, they are separate, they are isolated, both the secondary and the magnetic. So, any point on the secondary coil has a voltage of 0 relatives to the ground. So, when we touch any point on the secondary winding, there will be the no shock. So, because it is independent of the primary. So, the voltage is different in the 2 point of the secondary winding, which is the most significant advantages of the isolation transformer. So, it helps to reduce the risk of electrical leakage in the devices housing and provide the safety during the use. So, in isolation we use it. So, each primary and secondary winding has a different volt ampere characteristics according to the ratio of the turns on the primary and the secondary distinct. So, it is divided into 3 as we discussed: small power, medium power and the larger power. Another type of the transformer is the measurement transformer according to its utility. Now, the instrument transformer is another name for the measurement transformer, and measurement it will just check it will just measure the voltage. So, instrument transformer, another measurement tool that is usually utilized in the power domain. So, to separate the primary power and convert the current and voltage in the smaller ratio to its secondary output, a measuring transformer is used. Another is the distribution transformer. If we take the case of distribution transformer as we discussed, so we can take the example of that is typically 110 volt or the 230 volt. Now, another transformer is the pulse transformer. One of the most popular PCB mounted transformer. This is the PCB mounted transformer, and that generates the electrical pulses with a consistent amplitude, which is the pulse transformer. Means it generates the electrical pulses with a consistent amplitude. So, it is utilized in a number of digital circuits where the demand is isolated pulse creation exists. So, another type of transformer in this category is the audio output transformer. So, the another frequent transformer in the electronic industry is the audio transformer. It is specifically used in the application involving the audio where the impedance matching is necessary. Another is the instrument, and also the name is the instrument transformer is generally called the isolation transformer also, and it is electrical devices used for the transform the current as well as the voltage level. So, the most common use of the instrument transformer is of the safety isolate the secondary winding when the primary has high voltage or the high current supply. So, the measuring instrument, energy meters, relay connected to the transformer secondary side will not get the damage. So, instrument transformer are divided into the two categories. First is the current transformer, that is the CT, another is the potential transformer, that is the PT. So, the current transformer which is used to measure electricity and also for the protection. When the current is high to apply directly to the measuring instrument, the current transformer is used to transform the high current into the current required value in the circuit. So, the transformer primary winding is connected in series to the main, in series to the that we can say that the main we can attach it with the main supply with the series circuit. So, the various measuring instrument we can have the ammeter, voltmeter, wattmeter or the protective relay coil to measure and control the electricity. They have an accurate current ratio and the phase relation to ensure the meter accurately on the secondary side. The term ratio is significant in the CT. Another type of transformer is the potential transformer, that is the PT. That is, potential transformer is an instrument transformer which is used to transform voltage for the high value in the primary winding to the lower value in the secondary winding. So, this transformer step down the voltage to the safe limit value that ordinary low voltage instrument like voltmeter, wattmeter and watt-hour meters can easily measure. Another type of transformer based upon the winding are the two winding transformer, and another is the auto transformer. So, first is the two winding transformer, conventional winding transformer which is having a fixed number of the turns and they are separate, and it is a static machine that transfers electrical energy from one end to the another without changing frequency. So, a two winding transformer has a two separate winding, which is the primary and the secondary winding. Auto shares the same terms or the wires or between the input and the output connection. So, the primary and the secondary windings are not electrically insulated. The transformer which is based upon the insulation is first is the dry type transformer. This type of transformer not using any insulating liquid where its winding or the core is immersed into the liquid, that is to say. So, instead the winding and core are kept within a sealed tank that is pressurized with the air, and they are still very safe without the liquid. So, we have two types of dry type transformer, that is the cast resin dry type transformer, that is a CRT, cast resin dry type transformer, and another is the vacuum pressure impregnated transformer, that is VPI. Another type of transformer is the oil immersed transformer. It is also called the oiled filled transformer, and this oiled immersed transformer is a kind of voltage transformation device using an oil cooling method to reduce the transformer temperature. Unlike the dry type transformer, the body of the oil immersed transformer is installed in the welded steel oil tank filled with the insulation oil, so that the cooling effect will be there. When operating, the heat of the coil and the iron core is first transformed into the insulation oil and then to the cooling medium, and accordingly to the capacity size, it can be divided into the immersed natural cooling transformer and the immersed forced air cooling transformer. Another type of transformer which is based upon the phase, and you all know very well aware about that. First is the single phase transformer. So, what is this single phase transformer? Which accepts a single phase AC power and the output single phase AC, that is a single phase transformer, means it accepts the single phase AC power and output is also the single phase AC. So, a single phase transformer is used in non-urban areas as the overall demand and the cost are lower than that of the three-phase distribution transformer that will take the accept the single phase and that output will be the single phase. They decrease the home voltage to the suitable value without the change in the frequency. So, it is used as a step down transformer. For this reason, it is commonly used in the electronic appliances at the residences. So, you see, this is the one type of single phase transformer. Another type is the three phase transformer. So, a three phase transformer is made of three set of primary and the secondary windings, and we can say in each set of windings wound around one leg of an iron core assembly, and it looks like three single phase transformer sharing one joined core as it is defined in the diagram. You see it here. Here is a three type of, here we are having a one leg of the iron core assembly, right. It looks like a three single phase transformer. So, this is MVG transformer. What are the advantages of the transformer? We have discussed the type of transformer. Now, we discuss the advantages of the transformer. good energy transfer, voltage regulation and safety. If we talk about the good energy transformer, excellent in shifting the electrical power energy among the circuit with high performance. Another is the voltage regulation, offers the robust voltage production below several load situation. It may be high, it may be low. If we talk about the safety, isolation transformer increase the protection with the resource of the electrically separate high quality circuit component. Extended lifespan, given their sturdiness and capability to last decades with the proper protection. So, the transformer are an investment that is absolutely well worth making for the electrical powered infrastructure. Scalability, transformer are adaptable to the many applications for the reason that they will be synthetic in numerous sizes and capacities, from the tiny gadgets for the digital devices to the huge one of the electricity network, as we have discussed the power transformer. So, what are the disadvantages of the power transformer? First is the size and weight. Larger transformer can be heavy and widely, making the step up and the motion though. And another is the cost, high initial charge for setup and ongoing protection. Another is the losses, despite their moderate additional performance, transformer enjoy the energy losses. Moreover, there is a noise generation. So, the transformers, specifically big one, and can generate the noise in the direction of the operation due to the magnetic and the cooling mechanism, which can be problem in residential or the quiet environment. Another disadvantage is the environmental impact. Oil cram transforms are hazardous to the environment because excessive oil spills can pollute land and water. So, proper contaminant and the safety ought to be performed to reduce the risk. Now, these are the advantages and disadvantages of the transformer. Now, another point is the how the transformers are tested. So, what is transformer testing? How we test the transformer? How many ways we can test the transformer? So, in electrical engineering, transformer testing is a process for evaluating the performance of the transformer and measuring its working efficiency. That is the transformer testing. Means we evaluate the performance of the transformer as well as its efficiency. That is the transformer testing. Transformer testing is one of the important practices that is used to ensure the reliability and the safe operation of an electrical transformer. So, it provides a valuable information about the transformer's overall maintenance and helps to take corrective actions accordingly. So, we perform the different type of the test on an electrical transformer to determine any issues that can impact the operation of the transformer and cause any kind of fault or abnormality in the electrical system. So, transformer testing helps us to take corrective actions and maintain supply continuity. So, in electrical transformer testing, different type of tests are performed on a transformer depending on the type of transformer we are using, the need for testing and the data for analyzing the transformer operation. So, it is important to note that transformer testing is an umbrella term which contains the several different type of tests performed on a transformer time to time, so that it can be protect from the damage. So here we are having the some important transformer tests which are performed on the transformer to measure its performance, its reliability, its safety and other conditions. So tests which are performed in the factory are the type test, routine test and the special test. These tests, when it is come from the manufacturers, then these three type of test we can do: type test, routine test and the special test. Another type of test, the test which are performed in the site where it is installed. The first is the pre-commissioning test, second is the periodic or condition monitoring test, and third is the emergency test. So we are having the test first before the installation is the type, routine and the special, and after installation pre-commissioning test, periodic or condition monitoring test, and third is the emergency test. So it refers to the test which includes the various tests that are conducted to check the quality, performance and the safety of the transformer. So these tests are important in the manufacturing process and during the commissioning of the transformer. So some of the common tests are winding resistance test, insulation resistance test. Apart from other tests, we are having the winding resistance test, installation resistance test, temperature rise test, partial discharge test, impulse voltage withstand test. So these are the various tests that we will discuss further regarding in the elaborate manner, so that we can understand that what is the purpose of this test and how we can protect a transformer for the damage. So up to now we have discussed the transformer, types of transformer on the basis of its utility, on the basis of its action and on the basis of its winding, on the basis of its core. And then we discuss advantages and disadvantages. In the further lecture we will discuss the transformer testing. Thank you very much.